Let's take a look at energy, where we have work, potential energy, and kinetic energy in this type of example. Well, PE Coyote first starts off by trying to compress a spring, which requires quite a bit of force. So that force is the spring stiffness and the distance that he compresses it. Once Wiley does lift his feet, then that stored spring energy will be released, and it is sufficient to propel him to the edge of the cliff, and yes, a little bit beyond. Let's assume that the mesa that he is on is at an elevation of 100 meters. So what is his state of energy? Initially, he has zero velocity in the gravitational direction, or the y direction, and therefore his potential energy is initially at his MGH, where h is 100 meters. And then at the end, he will have reached 0 meters. So therefore, his state 2 will be at 0 meters. So he will have actually lost 980 meters per second squared times the mass, which would be in kilograms. So as Wile E. Coyote plummets to Earth, what will his terminal velocity be? You know that his initial velocity in the gravitational direction is equal to 0. So therefore, you know that he will have traveled a distance of 100 meters. And he had started off, depending upon what you have for a frame of reference, at 0 meters. And his initial velocity would have been 0. Gravitation acceleration is 9.8 meters per second squared. So therefore, we can solve for the time, which is about 4.5 seconds in order to reach the 100 meter mark. So the original question was, what was his terminal velocity? So, I ought to be able to go ahead and take my governing equation for motion and take the derivative of that. So when I take the derivative of x with respect to time, this term drops out. This is time to the first power, so it reduces down to just v naught. And 2 times 1/2 gives me my at. So therefore, I know what my time is, the 4.5 seconds. I know what my acceleration is, and I know that my initial velocity was equal to 0. Therefore, my terminal velocity is about 44.3 meters per second. So what would be the amount of kinetic energy that we would have? Initially, at state 1, we had started out with no kinetic energy because the initial velocity was equal to 0. But the terminal velocity was equal to 44.3 meters per second. So when I take that governing equation for kinetic energy, I find out that I have 980 kilogram meter squared per second squared as a measure of energy, but that's my kinetic energy. And the potential energy that we lost, it too was 980. So therefore, yes, we have conserved energy.